So in the fundamental mechanism of organic reaction, fission reaction, in that homolytic and heterolytic fission and free radical, because of heterolytic fission, carbanion and carbocations are formed. Carbocation have trigonal planar shape with positively charged. Carbon anion is more stable. Primary carbon anion is more stable, whereas tertiary carbon anion is least stable. So in a homolytic bond fission, free radicals are formed. Substrate is the molecule whose carbon is involved in new bond formation is called substrate. So in this reagent, so when the organic molecules undergo reactions, reagents are used. The reagents are known as attacking molecule to the substrate is called reagents. Attacking molecule to the substrate is called reagent. For example, bromine and methyl chloride are reagents. So if ethene is undergone reaction with bromine, dibromo ethane is formed. So here bromine acts as a reagent. When you see this reagent, there are two types of reagent. They are electrophile reagent and nucleophile reagent. Electrophile reagent is the positively charged or neutral species which is electron deficient. So example is given in your textbook. Example of electrophile reagents are chlorine, methyl, ammonium NH4 plus, BF3, AlCl3. These are electrophile. So the electrophile are nothing but they are the agent. They are the reagent which involved in the chemical reactions. Nucleophile. Nucleophile is a reagent. It is a negatively charged or neutral species with lone pair electrons are known as nucleophile. Br minus, NH3, RCOO minus, OH minus, these are nucleophile. When you see this organic reaction, here the arrow mark is shown. So the arrow mark shows that the movement of electron in organic reaction can be shown by curved arrow notation. The curved arrow starts from the point from where the electron pair is shifted and it ends a location to which pair of electron may move. For example, if double bond is there, if you show the arrow mark, the double bond is shifting from one point to another point, adjacent bond position. So the double bond, the sigma bond and pi bond is there. If the arrow mark shows this double bond to another bond, the pi bond shifted from one position to adjacent bond position. Next, so we can show this arrow mark from pi bond to adjacent atom, from atom to adjacent bond position. So movement of single electron is indicated by half-headed curved arrow. That is called fish hooks. So by practice, whenever we are learning this different type of chemical reaction, we use this. This is just you can understand if the arrow mark is given means what is the meaning of that. Hyperconjugation. What do you mean by hyperconjugation? If you see this, when chemical reactions are going on, in electronic interaction occurring between a double bond in a compound and a carbon hydrogen single bond in an attacked alkyl group. Under certain circumstances, the double bond and the single carbon hydrogen bond appear to behave rather like conjugated double bonds. Greater the number of alkyl groups, greater will be the hyperconjugation. If more alkyl groups are present, the hyperconjugation will be more. So it is nothing but it is an interaction occurring between double bond in a compound and a carbon hydrogen single bond. That's what known as hyperconjugation. Hyperconjugation describes the orbital interaction between the pi system and the adjacent sigma bond of the substituent or groups in an organic molecule. This effect arises due to the partial overlap of sp3s or CH bond with empty p orbital of an adjacent positively charged carbon cation. This all assumed. You have to assume that actually hyperconjugation is a delocalization of electrons. Delocalization of electron will delocalize through overlap between the p orbital occupied by the odd electron and adjacent p sigma orbital of the alkyl group. So in a alkyl group, CH3 group, sigma bond is there, and another one methyl group is attached in that. In that methyl group, one electron is there. That electron p orbital occupied by one odd electron. So during that time, sigma bond and p orbital overlap. So such overlap is known as hyperconjugation. Through this overlap, individual electrons can, to an extent, help to bind together three nuclei of two carbon and one hydrogen. Because of this, that they can bind together. This kind of delocalization involving sigma bond orbital is called hyperconjugation. In this formalization, separate bond into sigma and pi types. Hyperconjugation is the interaction of sigma bond, the interaction between filled pi or p orbitals and the adjacent antibonding sigma star orbital is referred to negative hyperconjugation. In this hyperconjugation also, negative hyperconjugation and positive hyperconjugation is there. Hyperconjugation, interaction between empty p orbital with adjacent carbon, hydrogen and sigma bond is called hyperconjugation. This type of overlapping stabilizes the cation because the electron density from adjacent sigma bond helps to disperse positive charge. Hyperconjugation increases the stability of the system. Hyperconjugation increases the stability of the system. So if you consider the ethyl cation CH3CH2 in which a positively charged carbon cation has an empty p orbital, one of the carbon hydrogen bonds of methyl group can align in the plane of this empty p orbital and this electron constituting carbon hydrogen bond in plane, and this p orbital can be delocalized into the empty p orbital. So before one video has shown in that the animation is shown very clearly. If you see this such interaction between empty p orbital with adjacent carbon hydrogen and sigma bond is called hyperconjugation. In general, greater number of alkyl group attached to the positively charged carbon, greater will be the hyperconjugation. More number of alkyl group is present means more hyperconjugation will be there, and so more will be the stability. Thus, the relative stability of carbocation, only methyl group is there means that is less stability than the ethyl group, diethyl group, propyl group, it goes on like that. So, hyperconjugation also called no bond resonance. It is also called no bond resonance. Such resonating structure of ethyl cation this was discovered by Baker and Nathan effect. So This was discovered by Baker and Nathan, so it is known as Baker and Nathan effect. The stability of carbocation increases as we go primary to secondary to tertiary carbon. The second is hyperconjugation, stabilization through donation of carbon electron in carbon hydrogen sigma bond to the empty p orbital of the carbocation. So these are the factors that affect the carbocation stability, increasing the number of adjacent. So methyl have least stable than primary, secondary and tertiary. So adjacent pi bond that allow the carbocation p orbital to be the part of a conjugated pi system. Adjacent atom with lone pair. Such type of hyperconjugation is present. When you see this, when these chemical reactions are occur, organic molecule like benzene whose properties cannot be explained by single structure, having the compound which have carbon single bond, carbon double bond. According to this structure, benzene should be have the bond length, different bond length will be there for carbon single bond and carbon double bond. Thus, structure of benzene cannot be represented by single structure. It can be represented by equally well by the electrically similar resonating structure. That means actual benzene ring is resonant hybrid of, that means the position of the double bond can be changed. So if you see this, it will look like a ring. So that is a resonance hybrid of benzene. These resonating structure are hypothetical and do not represent real molecule. They contribute to actual structure in a proportion to their stability. For example, nitromethane is a CH3NO2 has two resonating structure. In one structure, the double bond of oxygen will be removed and it is shifting to this adjacent oxygen atom. So has resonating structure because NO bond is nitromethane. In between N and O single bond and N double bond O, the actual structure of nitromethane resonance hybrid of two resonating structure which are called canonical form. Canonical form already we learned. So recall all those separate terms. So resonance energy. Resonance effect is the polarity produced in a molecule due to the interaction between lone pair of electron and a pi bond, or it is produced due to interaction of two pi bond between two adjacent atoms. Positive resonance, and also it is known as mesomeric resonance. Resonance effect or mesomeric effect. The transfer of electrons from one part of a conjugated system to the other due to the phenomena of resonance is called resonance effect or mesomeric effect. Transfer of electron, this all, everything is related to movement of electron and rearrangement of electrons. So the transfer of electron from one part of conjugated system to the other due to the phenomena of resonance is called resonance effect or mesomeric effect. So there are two types of effect, that is negative and positive. Negative resonance or negative mesomeric effect when the electron displacement is towards the atom or group. When the electron displacement is towards the atom or group, then it is known as negative resonance effect. For example, if the double bond is there, the double bond we are showing to the nearest carbon atom, then it is known as negative resonance effect. Positive resonance or positive mesomeric effect. When the electron displacement is away from the atom or group, it is positive effect. The electron displacement is away from the atom or positive that is known as positive effect. Electrometric effect. This is a temporary effect which involves the complete transference of shared pair of electrons to either of the two atoms linked by multiple bond on the demand of the attacking reagent. Positive electrometric effect when the electron transfer takes place towards the attacking reagent. Negative effect when the electron transference takes place away from the attacking reagent is known as negative electrometric effect. So resonance is the stability of system to move its pi electron in the system. The delocalized electron when show movement contributing structures are prepared. These structures are called resonating structure. Example, benzene double bond is there. If you rearrange the benzene double bond ring, it will go to the next adjacent atom such that it appears as a ring. So negative resonance effect and positive resonance effect. Negative is occur when the groups withdraw the electrons from the other molecule by the process of delocalization. Then it is known as negative resonance effect. For example, COOH, CHO, ketone group C double bond O, cyanide CN, this all shows negative resonance effect. Positive resonance effect, electrons are transfer of electrons away from an atom. Example of positive resonance effect, halogens, OH, NH2, this all the example of positive resonance effect. Benzene ring with amide group is known as aniline. Benzene ring with amide group is known as NH2 group is known as aniline. So aniline show positive effect in resonance effect. Next one is inductive effect. What do you mean by inductive effect? It is the permanent electron displacement along a chain due to the presence of polar covalent bond. That is, bond polarity is known as inductive effect. It is the permanent electron displacement along a chain due to the presence of polar covalent bond is known as inductive effect. If an atom or group attracts the electron more strongly than hydrogen, it is said to have negative inductive effect or electron attracting group. If an atom or group attracts electron less strongly than hydrogen, then it is said to be positive inductive effect or electron releasing effect. So the order of inductive effect, negative effect is CH3 group, it goes to CH2, then CH2, then Cl. In chloroethane, CH3CH2Cl, in which carbon and chlorine bond is polar covalent bond, is polarized in such a way that carbon attached to chlorine acquires some positive charge, whereas chlorine acquires some negative charge. So that positive, that is like a delta, it will be written. So that is inductive effect. The fractional electronic charges of the two atoms in polar covalent bond are denoted by symbol delta, and the electron density within covalent bond are shown by arrow of that point, and plus delta and minus delta end of the polar bond. So in CH3, CHCl, CH3 to CH, it show delta plus, double delta plus, and CH2Cl it shows single delta plus, and Cl is the negative inductive effect atom. So carbon 2 occurs very small positive charge denoted by delta delta plus. When you see this resonance effect, carbocations are more stable, and a tertiary butyl carbocation, for example, is more stable than isopropyl carbocation. Primary carbocation are highly unstable and not often observed as reaction intermediate. Methyl carbocations are less stable. The difference between inductive effect and resonance effect is that inductive effect is describe the transmission of electrical charges between atom in a molecule, whereas resonance effect describes the transmission of electron pairs between atom in a molecule. So when the chemical reactions occur, these all those changes occurs. If you see this application of resonance effect, dipole moment, bond length, what is the strength of certain compound, what is the stability of intermediate, everything can be understood by the resonance effect. And these are all the different terms which we have to use in our lesson. There are few type of chemical reactions are there, that is substitution reaction, addition reaction, elimination reaction, rearrangement reaction. In the substitution reaction, reaction in which atoms of group of atoms are replaced by other atom are called substitution reaction. Addition reaction in which molecule is added across double or triple bond are called addition reaction. Elimination reaction in which a molecule is eliminated or removed and result in formation of double bond are called elimination reaction. Rearrangement reaction, those reactions in which only rearrangement of atom takes place without any loss or addition of molecule are called rearrangement reaction. For example, NH4CNO on rearrangement it gives NH2CONH2. So these are the different types of chemical reactions which are involved in the fundamental reaction mechanism in organic chemistry. Here are the example of inductive effect group: positive inductive effect, negative inductive effect. So read the textbook, complete your classworks. By this we are completing this lesson. All the terms are very new term. Everything you have to learn. I will send this all the definition of this lesson. Images, you can see that image and you can utilize for your learning.